Okay, so I am still setting up here, and let's see. I'm gonna check about my take off the blur. I think that's a little better. Okay. Um. All right. Let me just refresh my screen here. I am making sure that I am running. Hang on a second. I wonder if it's enough brightness. Hmm. Yeah, it's too bright. I'm still setting up. Hang on a second. All right. Yeah, that should be okay. Second here. Let me just kind of trying to get all of the brightness off myself here. Just a second here. Settings. Somehow the blur would smoothen it. That's better. Yeah, I'm not as hot in terms of like I'm not glaring as much. Oh, I got a greeting here. Okay, let me just make sure that. Let's see here. I want to make sure I can hear myself. Okay, yeah, it seems to be working. All right, still getting over that. All right, I got a hi in the chat here. Hi, Decibel. I hope I pronounced that right. All right. Okay. And banners. There we go. Okay. So, yeah, we're back to doing my usual thing. So, I'm continuing the math stream. However, if there's anything that you want, I mean, you could shout it into the group chat. The way this works, I'm trying to bring IRL streaming to, I guess, our community. What is IRL streaming? Uh, it's basically where the streamers are able to interact in a parasocial way with the presenter. And the way they do it is they send a donation, and then the streamer has to react to the donation. Again, you don't have to do that. It's just I watch IRL streaming, and I think it's absolutely hilarious. And the way that the audience participation takes control of the stream and affects the outcomes and the direction of it. But anyway, I'm going to continue with the set program. If you have something, you could drop it in the chat. Like I said before, the way that works is if you sent the Venmo donation right there on the screen, then I have to react to it. Otherwise, I mean, I'll still interact with you. But anyway, so here we go. I am continuing from where we left off. Let me just get myself here. There we go. Okay. I'm going to add myself. Hang on a second here. There we go. Okay. So the reason I haven't streamed for the past couple of days has just been very busy with work. That tends to happen. But anyway, let's get some stuff going here. All right. We're going to continue from where we left off. Okay, we are doing, this is going to be quite a bit different than what we've done so far in my previous streams. Section D, and then we're starting with 39, okay? All right, so I'm going to write this out real quick. Right. I might change my panels. I've got a calligraphy setting on this thing right now. I don't know if I like it yet. We'll see. So try to read this, and then I will read it. Now, I didn't prepare for this, as always. I'm having fun with it. So it's quite possible that I screw it up and then I have to go back in the book. And then the book will tell me whether I did it right or wrong. Speaking of the book, why don't you look inside the video description? This book is an open source book, and this is called The Book of Proof, third edition by Richard Hammock, and it is in the Creative Commons. I have the PDF linked in the description where you can go. You can actually go and buy it from Barnes and Noble, or you can just download it right now. You could have the book right now, and then if you scroll to the end of the book, you can see the answers before I even finish it. So that's an option if you want to follow along and you want to do this. I can take this off. Here we go. So, right, let's read the right here what we're going to say. So we have, this is set builder notation. We have section D, question number 39. And the set, this is now what we have is we're using, notice the different kind of brackets. So we have X and Y. These are going to be ordered pairs. So we're going to order some pairs here. And then we're going to say such that X contains 1 comma 2 and the square brackets, and Y contains 1 comma 2. So what we have to do is we have to order the pairs. So let's just write some out real quick. Now this right here, the question actually has to say sketch it. So I have to first order the pairs and I have to draw it. So I just go in order. We're gonna go X, Y, X. So basically, what if this is 1 and this is x1, we're going to say x1, comma, this is going to be x2, and we're going to say this is y1, y2. So we're going to go x1, y1, x2, no, x1, y2, x2, y1, x2, y2, right? So we're going to have 4 sets of ordered pairs. So let's go with x1 and y1. So that's going to be here. We're going to use, this case, we're ordering them using parentheses. So that's going to be 1 comma 1. All right. The next one, we're going to say x1, y2. So that's going to be here 1 comma 2. We're going to say x2, y1. That's going to be 2 comma 1. And x2, y2, 2 comma 2. All right. So we want to sketch the following thing on here. So basically what we're doing is we want to draw, I want to see if it has to fill it in. Right now, it just says this is the section that contains, doesn't specify, I just want to, okay. Yeah, as far as I can see here, yeah, this should just be, they just want these locations on a chart. And if I mess this up, I'm going to know pretty quickly. Again, our rule is it's totally okay to make mistakes in math. Totally okay. What you want to do is understand the process. It's not okay to be lost and not understand the process. I mean, yes, it is okay in the sense, but I mean, if you are in class and you don't understand what's going on, you really should ask questions, even if they sound stupid. All right. So now we have, this is our X, this is our Y coordinates. So X traditionally, and we're going to stick with this, is that X goes horizontally. So this goes, we're going to say this is -3, -2, -1. And then this -1 will apply to both. This is going to be -2. This is Y coordinates now, and this is going to be 2, 3. And then we're going to say 1, 2, 3. Okay. So what we have right now is we're going to use the coordinate system, and let's go with the ones that we wrote out. We're going to say 1, 1. All right, then we're going to say 1, 2. So that's, we're going to go x1 and y2. This is our second one. Third one, x2, y1. And fourth one, 2 and 2. All right, so we just wanted to sketch the following sets of points. All right, so we sketched the points. I don't know if they want it filled in or connected. Usually they denote it. I haven't done this in a while, so I'm going to look at the answer now and see if I had to fill it in. I'll understand what I did wrong if I didn't answer this correctly. But let's do that right now. Solutions. Okay. Okay, so what happened was this Yeah, they wanted. Oh, okay, okay. There's an important point that I missed that they have it as filled in. So I'm just gonna first answer it correctly. I'm gonna fill this in, and I'm gonna tell you why I made that mistake. All right, this is the correct answer. Now, what I wrote was not complete. This is the correct. So if I had just submitted that, I could have gotten partial credit or I could have gotten no credit. Depends upon how stringent the teacher was. So the reason is when you do coordinates on a line, just let's take a line. So this is going to be 0, -1. This is 1. Okay. So now, if we were to draw a line, so this right here is open. This right here is closed. So what we can say is x is, it's going to be greater than or equal to 0, but it is less than 1. So this is what it's saying. Now, another way to write, this is open. You could write open like this. You could write open with open and then closed with a square bracket. So this kind of coordinates, now, this is how you're going to annotate it. This refers to a closed bracket. This means open bracket. And because I had not realized that, I mean, this right here, this is correct. That's the right way to order them. But they are meant to be in square brackets, meaning that you have to fill it in. The whole thing contains it. Anyway, the answer now is correct. We're going to continue now. All right. Okay. So again, it's okay to make mistakes. The important thing is to understand the process. E41. Okay, we are going to do this. Again, this is saying ordered pair of x and y such that x contains, this is the closed range from -1 to 1. Now what they're saying here, and then y is equal to 1. All right. So this right here, this important thing is saying that the range of x, if it's on the line, 0, 1, -1, what they want to know is that this is closed and this is closed, and this whole range is complete. Now, the next thing that we have to do here, this was just if we want to talk about x by itself in a vacuum. However, if we're talking about XY sets, then what we're going to do is we have to draw it in XY coordinates. So this right here, this is a two-dimensional, this is a one line is basically a one-dimensional thing. It's a line. This is two-dimensional right here. So Y, X. So now what we have is, okay, this right here, we're going to say this is 2, but we're going to say this is 1. If y equals 1, that means that this whole line right here is y. It just goes out the whole way. That's all y is. But there is a constraint here placed on us. And the constraint is the fact that x is -1 and 1. So let's just write the sets real quick here. We're going to say x1, and this is going to be x2, and this is just going to be y1. In this case, we're going to say it's going to be -1. Since, yeah, well, that's fine. We're just going to write ordered pairs for now. X1, comma, Y1, and then X2 is going to be, it's -1, 1, and it's going to be 1 and 1 again. So that means that the range of X, now remember, the way the X ranges, the Y occupies this plane, but the X ranges on the Y. So we're going to say this is 1, say this is 2, -1, -2. So now we are going to range on the Y from 1 to -1 right here. Okay, and that right there, the thing that I wrote over, that was just meant to be a 1 there. That just denoted the height of the line. So basically, that should be the correct answer. And check it. All right. Yes, the book agrees. That's the correct answer. All right, let me just answer a question real quick. Okay, so Decibel Chaos writes, so I'm wondering, and this is totally random, but is there a name for the fact that an automorphism of a fine set of trajectories process, is there a name for the fact that an automorphism of a finite set of trajectories produces? I was thinking decomposition cycle, but can you help? Um, Sorry, I'm actually not familiar with what you're talking about. I wish I could help. So in terms of where I'm at, I'm not working specifically in the area. So either it's much more advanced than what I'm in, or it's not related to what I'm working in. So as you can see, these are technical terms you're talking about, but I'm not gonna try to guess or mislead you. It's not something I'm familiar with. Sorry, Decibel. But thank you for asking, though. Um, and hey, you should panel up sometime. That's the other thing is with this thing, if you have a StreamYard account, I can panel up with people. I can invite them to my panel. So that could be fun. Okay. Okay. Right. We're gonna continue now. File. New. Okay, good. Next up. D43. All right. Okay. So here we go. So we have the xy coordinate set such that the absolute value of x equals 2. Now this could also be the cardinality. I got to read it what this thing wants. I think that it means the absolute value of 2. So think about it for a second. The absolute value of 2 of x is going to be 2, so that means that think how that's going to reflect how it would be in an xy plane, what that would mean. What does that that mean in an xy plane? That's the question you want to ask yourself. Okay. So, we're going to say I'm going to have a crack at it here. I'm going to say that first you want to think about what you want to answer, right? You want to think about where to start on this. Well, the first thing we want to know is what does this absolute value of 2 mean in terms of the x? I'm going to say that what they want to know is that what are all the possible ways in an xy plane where the absolute value of x is 2? In that case, that would mean that it's going to be negative 2 and it's going to be 2. And in this case, these are just those specific points that we want to see. So this is going to be interesting. I might not graph this correctly. A y contains, now here's the thing, this is such that the x is 2, so those are the things that it is, negative 2 and 2, and y contains 0 and 1. So let's see how we can graph this. We can try the previous way to just write some pairs, order pairs. So this can be x1, y1. So we're going to say negative 2 and 0, negative 2 and 1, 2 and 0, 2 and 1. The difference being is that the y can range from this, but the x contains it. Well, let me see here if I get this right. Y, x. Okay. Yeah. So first, let's establish the x's. 1, 2, negative 1, negative 2. So we are going to say that the x's are right here. They're just 2 points. It doesn't say that it ranges from it. It just means that it's just those 2 points. But the y, let's get our y is going to be here. So we're going to have 0 and 1 for y. That's all you want to know, really. I say 2, but all right. So All right, x, we're going to say -2 and 0. Got that one already. -2 and 1. We're going to say this is going to be 2 and 0 and 2 and 1. Okay. Now, the y ranges from this, but the x contains. I would say it would probably be like this. This is how my instinct tells me. I could be wrong. But I think this is going to be the way to answer this. Let's find out. Let's find out if I'm making mistakes. It's probably a good thing because that means I'm being challenged. But I did answer this correctly. So again, you got to pay attention to all the little details. The reason I got the first one, 39, wrong was because I just kind of blew past, and I haven't done this in like a while. But the fact that I wasn't thinking about the square braces, as in, that contains that area. However, in this case, I was absolutely correct because I analyzed it. It took my time. You got to take your time on the math stuff. It's super important. So this is how I was able to solve that correctly. All right, let's go to the next one. I need a drink of water. It's a little late. I'm usually this close to my bedtime. I'm usually at work by about around sunrise, but not too early in the summer because people get mad if you start your power equipment so too early. So normally in the summer I start work at 8. Now that it's sometimes it's even 8:30 nowadays. It depends. Kind of depends upon when sunrise is. You want people just to wake up and not to wake up to the sound of my people. But anyway, let's continue. Here we go. 45. 45. Okay. There we go. They want to know x and y sets such that x and y contain the reals. This is actually good news, I think. Okay. Yeah, excellent. Absolutely excellent. All right. Now, if you did trig before, you're going to look at that. You're going to say, I know what that is. And that's it. You know the answer. Good for you. You can all go home now. So this right here, I immediately knew the answer because I recognized the formula. And however, what we want to do is this contains all of the reals so what is the, let's just think about what all the options are. So I guess we know that we can use fractions, we can use anything we want, but let's just try a set. If let's say this is another way you can do this, x and y. Okay, if x is 0, what would y have to be? Well, it could be 1. Another one, it can be -1. That's another option. So that's good. So x can be 0. What about if y is 0? X is also going to be 1 or -1. Okay. And then pretty much, so then this is where it's good to have a calculator nearby. I want to try a few other numbers. Where did I put my calculator? I'll show you guys a few things. I had it here. Okay. There it is. It's right behind me. This calculator right here. Fun story. Let me tell you about it. Okay, this calculator is a Texas Instruments TI-86. That doesn't sound familiar. This one goes back to 1997. It was given to me by my third dance partner's mom, and I kept it in good shape because I knew of the power that it possessed. I didn't use it at the time because I spent my many years training and skating, but I knew that someday it would come in handy. And it has. I'm just going to pop myself here so you can get a good look at it. There we go. So this right here is a TI-86 calculator. I mean, some of the modern ones, they can do stuff that this thing can't, but still, it's very useful. It still works. 1997. Isn't that crazy? Mhm. There we go. Okay. Now, let's try here. Okay, so now the let's see here. We have let's try. Okay, that would work. So another thing that we can do, for instance, because we're in the reals, we can use decimals. So we're gonna, and because this is squared right here, because that way, if I know like I want a number, like I want half, right? We're gonna say x squared equals half, then we can just square root this, and this is roughly 0.707. Or let's say 0.7071. That's fine. So we're gonna say if x is 0.7071, y is also gonna be 0.7071. Okay. Now, the next thing that we know is that if x is negative 0.7071, y is also going to be 0.7071. All right. So this is some really cool stuff, right? Really cool stuff. Let's graph it. I want to ask you something. We notice something. You see any numbers that are big? They're all small numbers, right? They're 1 or less than 1. It's kind of important. Okay. So what we have right here, if x is 0, y is going to be 1. So x is 0, y is 1. All right? If also y is minus 1. Cool. All right. Now, if y is, here, if that's if x is 0. Now, if y is 0, right here, if y is 0, x is going to be minus 1 or 1. Okay, cool. Now, the 0.7071, right? If x is 0.071, now this is 1 right here. This is roughly where we're going to say that's approximately where that's at. Okay, so we're going to say it's about here. If that's the case, y, this is, I'm sorry, if this is x, that's actually y. This is the y's area. This is for 0.071. 071 for x, we're going to say, and for y, 0.7071. Okay, so that's going to be roughly about here. All right, now, I'm just paint over these, get them out of the way. Okay, good. Now, we're going to say if here, we're going to say this is negative 0.7071, and this is also negative 0.7071. Okay, so now notice that if they're both negative, they are both going to be here. Also, so if now the other thing is if x is negative, y is negative, there's two more sets that I forgot to write in here, which I know that they exist, but I didn't write them in here. If x is negative 0.7071, y, it can be negative or it can be positive. Why is this all true? Is because the squared part right here, okay? Because we're squaring them. And if you have a negative number or a positive number, you square it, you are going to end up with a negative or a positive number. Cool stuff. negative 0.7071. So in that case, let's take a look at that. X is negative 0.071 right here. Y is positive, so we're negative. So we're going to say it's about here, right? So that's roughly where that's at. And the same thing here, right here. So now what we have right here. There we go. I'm going to draw this. It's probably, again, I'm freehanding this, so you have to forgive me if it looks a little funky, but you have to take my word for it. That's a circle, right? This is meant to be a circle. All right. All right. Okay. Let's check the book. Yep. The book agrees. Good stuff. All right. Now. Okay. D, and then we are doing 47. All right. All right. So we have the X and Y set such that X and Y contain the real set. Okay, and Y is less than or equal to X squared minus 1. Okay. Wait a minute, no. Y is greater than, I read that wrong. Y is greater than or equal to X squared minus 1. So, we can think about this for a minute. So we know that we can rewrite this equation, by the way, but we can try this. Okay, so let's just solve it. Let's take a number. Say X equals 0. Or no, we're not going to use this. We're going to take our equation here, and we're just going to start solving this thing. So look, math, you can only make progress by putting pen to paper. You have to write it. You can't just stare at it and hope something happens. So we have our equation. Y is greater than or equal to X squared minus 1. So we're going to say that X is 0. So Y can be negative 1. It can be 0. It could be 1. It could be 2. It could also be anything in between. So it just goes on. We can say that, well, what if X is like really, really, really small? Like let's say X is approaching infinity, right? The only thing that we know about X is that can we get X to be like if we put any number in X, let's see what happens. Can we get Y to be negative 2? That's what I want to know, right? Can we get Y to be negative 2? If we put like say 3 in there, right? I'll show you what happens. Again, we can't think, we have to try. We're going to say X equals to 3, so that Y is equal to 8. 9, let's see here, 9.5, 10.575, whatever. So we know that that's the case. Let's try making X negative 1. What happens if you go with negative 1? Okay, if X squared becomes 1, so 1 minus 1 is 0. So okay, we're getting some progress. We've made Y become 0 now. Okay, but not really, because that's still so we didn't get -1. So it has to be greater than or equal to. So it has to be greater than or equal to 1. So that's going to be 0.5, 25, 100, dot, dot, dot. So, okay, that didn't work. Let's see here. So far, and then if we go, let's just continue going lower. X equals -2. That makes it squared, makes it 4. Then y can be 3, 4, 5, 1,000, whatever. Say 1,000. Okay, whatever. It could be anything that's those numbers, right? Okay, so it seems to me that y could be any arbitrarily large number that's positive. The lowest y can be is -1. I can't figure out a way how to make it because no matter what number I throw in there now, like if even if we throw a fraction, right? For instance, let's try something like this. And this is why it's great to try stuff, right? Let's say here we're gonna say 0.3. We're gonna just try a 0.3 fraction. Okay, 0.3 times 0.3 because we got to square it. That's 0.09, and then we're -1. So that's gonna be, this is this equals to 0.09. So -1. We take that off of -1. So negative 0.91, comma, negative 0.90 or 9, negative 0.89. Let's see here. Negative 0.5, negative 0.2. Let's say 0, 1, 7, 9, whatever. That's 10. Okay. So, yeah, we've tried fractions. We tried using relatively large whole numbers that are positive and negative. Again, this is relatively because like I can throw like say 100 in there, right? X squared, it makes it if we square that, that's gonna be what, 10,000, and then -1. So y has to be greater than or equal to 9,999. Like for graphing's sake, it's good to know that it's there. That's why I have numbers like 100, 1,000. But what I want to do is look. It's like imagine this: you're in a forest, right? But you don't know how big the forest is. Well, you immediately start walking and figure out a way to walk in a straight line. Like you can use the sun or the angle of the sun to figure out that you're heading straight, assuming the sun's out. And then you just keep walking in a straight line or a straightish line, or you see some mountains in the distance and you walk toward them, and then see if you hit a fence. And then if you hit a fence, you follow that fence to the next angle in the fence, and then eventually. Now again, this is assuming this is just like a small little park that's, I don't know, 100 acres or whatever. But that you could explore over the course of maybe a couple of days to figure out. Now to walk that kind of distance, assuming the terrain isn't terrible, and I know because I take my dog to a park that's 123 acres. I've explored it pretty thoroughly, but it's taken me years to find out all its little secrets, and I'm sure there's still plenty there. But getting back to what I'm saying is, we have this imaginary fence that we're trying to figure out where the limits are to how far can we push it. We know that y can be arbitrarily large, and then we know that we can throw any arbitrarily large number at x. But what happens is that y has to be -1 just as large. So just to prove that, and this is something else. I want to get out of balance here. So let's just say -10 because it's gonna be bigger than I want to graph. -10 squared is positive 100. Y is gonna be 99. 100, 101. Let's see here. Let's see 101.5 and so forth. So we know that. That's great. Positive 10 is going to be same thing. It's 100. So 99. Let's see here 101, 102. Let's see here 1000. Okay. So we see that. Okay, so that tells us that the lowest, we know x can be arbitrarily large. We know that negative x can be also arbitrarily large. There's no constraints on that. And we see that y can be arbitrarily large only in the positives. In the negatives, the lowest is going to be -1. So this is why it's important to really test and see what you're doing. Just say that -1, -2, -3. Okay. Let's see here. This can be 1, 2, 3, -1, -2, -3, 1, 2, 3. Okay, this is y, this is x. All right, so based on what we know, it can be equal to, so it can be -1. So we know that y can go down as low as -1, and it can go as far as it wants in x in the negative, as far as it wants in x in the positive, and as far as it wants in the positive y. I'm just going to try to just kind of shade this in. So I still want it to be somewhat read. You can read it. So this is just shading it in. Okay. That's all it is. We're just shading it in. Okay. So basically that's what we can see. That whole area just goes up. And it goes arbitrarily far in 3 of the directions, but it's limited by y equals -1. That's what I'm reading. Now, I could be wrong, but that should be correct. Let's find out. Okay, and then we have... No, I did not answer that correctly. I mean, I was correct, except... All right, here's what I did wrong. Yeah, hang on a minute. This is 47? Yeah. Why? Let me just read this for a second. This is why it's good to see, because this is a learning process for me. I'm doing this as much for myself as anyone else. Let's see here. Y contains reals. X is greater than or equal to y squared minus 1. So if x... Oh, okay. Okay. Right. This is where I went wrong. Let me show you where I went wrong. If another way to do it is that what happens when x equals 3? Y is 8, 9, 9.5, but it can't be more than 8. And I'm saying when x equals 3, y can be -1. So that's where I was wrong. I wrote this incorrectly, and I'm going to fix this. So let me show you another point so you understand where I screwed up. Let's see here. X equals -2. Okay, if x is -2, back here, I said y can be -1. I said, now if you look at that, it has to be 3. It has to be +3 in the y. It cannot be -1. So this is where I messed up. The answer in this chart is correct. That information is correct. I drew this incorrectly, and this is why it's good. And this is actually a good thing that I messed up, because you learn better when you screw up. Just try to get rid of this. You remember things a lot better when you make mistakes. All right. Yeah. There you go. Okay. And so now let's go back and do this. So my information that I've printed out here is still correct. So we can still use all that. Now, the other thing is, this is a formula that should have been familiar to me from trigonometry, but either I'm just tired or haven't done it in a while. I totally slept on it here. Okay, so let's put them in here. If x equals 0, y can be -1. Okay. Now, if x equals, let's say x equals -1, y can be 0. And also, if x equals 1, y can be 0. So here and here are our points. Okay. Now, We also know that it can be within this area too, so this is fine. But it can't be any further out than that. If x equals -2 or 2, y can be 3, 4, 5, but in the positive. So that means x now is here. X is here. We know that it can be here, here, all this area here. Okay, so that's fine. We know it's here. It can contain this area, and then so basically what we have is we have a parabola like this. That's a parabola formula, and as it grows, the y's ability is constrained. It could still go, but it is constrained on either side by the x like this. So this is what it should look like, the parabola. So remember the parabola formula. It's much easier to get this right if you remember certain specific formulas. The parabola is one of them. Good. Okay, so let's continue. Just so you know, by the way, this is a parabola, and this is a hyperbola. Anyway, I don't remember the formula for that. When I start going over a trigonometry book, we'll be able to do all that. But anyway, let's continue now. So we have, that was 47. All right, let's do 49. Okay, I don't know if I can get this one right. Let's see it. Okay. We have x and then x plus y such that, so this is one of those things where I don't know what the x plus y, what they exactly want me to do there. This is probably going to be some more of using up, I think I know what's going on. Okay. All right, well, okay, y contains the integers and x contains the reals. So if x contains reals, x can be any number that we want. It can go up or down. And if y, so let's try this. Let's see what we get. X, y. So if x is 0, y can be 0, -1, y can be 1. It just, y can't be, it has to be whole numbers. So, but it can be any number. It could be -100. It could be positive 100. Okay. If x is, let's say 2, I don't know, y can be any number as long as it's a whole number. Let's see, -100. See, 100. We can go also be 2. It could be 0. If x is, so again, so you could see, what, for the sake of the argument, x is real, so we're gonna say, how about 100 pi? So it's 100 times 3.14159. So this is roughly 300, 14.59. So so basically we have here, so this is approximately, let's see, 314.59. We're just gonna say that. So that can be that number, but it has to be a whole number. So let's just say we're gonna start with our -100. We're gonna say 100. Let's say 2. We're gonna say 0. And we'll say we can 314. So y cannot be a fraction of any kind. X can. If we were to say this, so let's just do some ordered pairs. If x is 0, the second is going to be x plus y. So it can be, we can say 0 and then 0 plus 0. Okay, that's a set right there, which is 0, 0. Let's say It's going to be 2. The other set's going to be, I don't know. Let's just say 100 plus 2, which is equal to 102. And 2. All right. And then again, the second part can have it because let's say that it's going to be the first part 314.59. The second part, and we'll just take it minus 100 minus 100. Actually, it's x plus y. So we're going to say it's 314.59 minus 100, which equals to the first part 314.59, comma, and then it's going to be 214.59. So again, we have to do these numbers. We have to experiment with them just to get a real feel for what's going on. But what I was able to establish why this was important is that I showed that the second part can have a fraction. And then we can say, for instance, again, these could be, I'm using positive numbers. We can just as easily say that if x is going to be, say, negative 10, y, let's say it's going to be negative 10 also. So we're going to say negative 10. Actually, let's say y is negative 5. Negative 5. So plus negative 5, which equals to negative 10, negative 15, right? So we can see that we can have arbitrarily large negative numbers, arbitrarily large positive numbers, and we have the 0, 0. So x, y, I just see a big old box. Now, I could be wrong, but this is what I'm seeing, all right? Okay, let's see what the book says. Now, the question is how they fill this in. Let's see here. 49. 0, 0, x plus y. I have to think about this for a second. Be x plus y. So if x is a half, x contains reals. So x can be any number. So if x is 0, y contains integers, x plus y, such that x contains reals, y contains integers. These are x's. So x is 0, 1, 2. X contains reals. Okay, so the way they did it, now this is the part that's confusing me. They went like this. They just drew lines, which could be signified to mean that anywhere in the box is fine, but normally I would understand that as being shaded in. So, but at the same time, all of the numbers that the lines cross through were whole numbers, and x contains reals. So the way the ordered pair would work, like to say that x is 0.5 is valid, the book does not have a line running through 0.5 here for the x, but that is a valid number according to the equation. So I'm going to take their interpretation to mean the same thing. I'm going to say that these two are the same thing, that the way I shaded my box and the way they shaded their box, these are meant to be shadings and not just lines running through it. It could be that I'm off on something, but you know that sometimes that's the way it is. I think that I answered it correctly, but if I'm wrong, someone just leave a message or hit me up. If it turns out that, I mean, this is the kind of thing that, yeah, I mean, causes satellites to crash at some point, fall out of the sky onto Mars because someone did the math wrong. So it's important to get it right. Important not to have an ego about it, but at the same time, sometimes you just got to keep rolling with it. Okay, here we go. D51. Okay. This is my longest string. We're only doing, I don't know, like what? We're doing only 7 questions, really? Yeah, only 7 questions today. But yeah, as you can see, it slowed down quite a bit, even though this is still section 1.1. It takes more thinking. Also, graphing just takes longer in general because it just does. Maybe that's why. X contains reals, but no. Let's see here. No, that's fine. Okay, such that. So now they're saying the X and Y. Now, whenever you have an ordered set like this, this right here is kind of like a general thing. For instance, if we're going to say X, Y, and Z, we're really talking about R3. Okay, and R3 would be like this. Here, here, and here. So I believe it goes X, Y, Z. I think that's how we do it. Anyway, you do this in Calculus 3. That's very hard to graph, but yeah, it's possible. But this means it's R2, so that's just kind of a given. But what they're doing is they're saying such that they want to have this equation. Y minus X times Y plus X equals to 0. So they're saying this equation exists in R2. R2 means this. This is R2, X, Y. Or two-dimensional space. R3 means three-dimensional space. R means the real set. It means that R1, or which is equal to R, it refers to the number line. In other words, just one line, but it just goes on infinitely forever. All the numbers are there. So now that we established that, so what they're saying is, here's an equation. It exists in XY space. So we just got to solve the equation and make it work. All right. So the equation's already factored for us. All right. Well, let's see what happens. X, Y. If X equals 0, 0 minus Y times 0 plus. So we're going to say 0 plus Y minus 0 Y. So that means that the only way that would work is Y has to be 0. All right. I can't think of another way where that would be 0. All right. What if X is 1? All right. Let's see what happens if X is 1. 1 minus Y times. By the way, okay, there's a much easier way. Plus X, right? Watch this. We're just going to take one of these and we're just going to say this. Y plus X equals to 0, which is equal to Y equals to negative X. And then we're going to say Y minus X equals to 0, which is equal to Y equals to X. Oh, okay. So any number is going to be, that we want, is going to be itself. So the way it's going to plot, any number that we have, it has to, so if X is 5, so if X is 5, Y is negative 5 and 5. All right. If X is negative 5, Y is going to be 5, and it's going to be negative 5. All right, good. So then, all right, let's just roll with that. See what we get. So we know that 0, 0 is here. And then let's do this. Just gonna jump a little around here. We're gonna say 5, -5, -5, xy. So we know that these points are all valid. And we know this point is valid. We got 5 points on there, right? Okay. Well, so taking what we've already established, we know that if x is 3, you'll go over here, we look at it. Well, in that case, y is going to be both 3 and -3. -3. If x is -3, y again, -3 and 3. Again, it doesn't matter which order I write them. It just means that it's there. So, all right. So we're going to say this is going to be 3. All right, we're going to say this is 3. We're going to say this is -3 and -3. All right. That means if x is 3, y is 3. Oh, by the way, I kind of wrote this wrong. This is where the 5s need to exist. Look at that. We're forming a pattern. Yeah, there we go. Let's hit the 3s. All right. So now we can just go ahead and mark it. Okay. Oh, that's interesting, huh? Okay, so let's just view what we did here. Just gonna make this line a little clearer. Okay, let's go back to the top. All right, so we know that this is x and y. They exist in R2 space. This is R2 space. Then we know what they're saying. Let's do this equation. We have the set where x and y exist in R2 such that this equation equates to 0, right? So we have this equation. In this case, ordering the pairs means solving this equation. We did that. So this is already factored. When you have it factored, you can take pieces and then put them out here like that. Okay. So that's what we did. We took our pieces out and then we solved the equation. So now this is the solved equation. Because the y can be arbitrary, we just have to solve for y, and that gives us x. And in this case, y gives us both the positive and negative x. But the reverse is true also. The x will give you the positive and negative y, because we can multiply this one right here by -1, -1. So suddenly this would be negative x equals to, or sorry, positive x equals to negative y. So that way we know what the relationship is. And knowing that, we were able to establish the pattern. Every time you hit a number, if it's 100, right, that means that it has to be -100 and +100. So say we're just going to fast forward. Let's say this is going to be, let's see here, 100. See up here, we're going to say 100. Is it going to say, so that means positive 100, -100. We line it up right here, for example. So the line continues indefinitely. So we've established that. Now let's see what the book says. All right. The book agrees. All right. Well, that's it for today. This is my longest stream so far. We managed to get somewhere. Look at that. We managed to complete section 1.1, the very first section, and not without mistakes either. So the next part, okay, the next part's not that bad. We're going to be writing sets. This is going to be set multiplication. This is actually going to be pretty fun. And then we have to sketch Cartesian products, similar to what we were doing right here. Yeah, and then after that, so I'm just looking at this ahead. I can probably get through section A and B for 1.2 pretty quickly. Section 1.3 probably would take another day, and then 1.4 We'll take a day. This thing goes on to 1.8 before we get to the end of it. So yeah, a lot of really, really cool stuff in here. A lot. And then we start chapter 2 with logic. At this rate, maybe another month until we get there. We'll see. I hope you guys enjoyed the stream. Anyway, let me switch back out to me. Thank you all so much for watching, and I will see you next time.